Alright, so the next LabVIEW topic I wanted to go over is how to write data to a file. And unfortunately I've done a bunch of stuff here, so I'm hoping I can find what I need. This one? Okay, so from the last time I've got this nice little from the I guess it was the shift register part. I have this nice little I'm blanking out on the words. I've got this nice little routine that, you know, we can take a moving average. So I'm just going to go ahead and use this one as a template for the next part. So what I'm going to do to write to a file, the way we think of writing to a file is we open a file or create it. We write to it as many times as we need to capture all of our data, and we close it. So we open it, we write to it a bunch of times, and we close it. So that means we open it once, write it to it, and then close it once. So therefore, that's going to dictate how we want to set up those operations, because opening the file is going to happen outside the loop. And I'm going to give myself some room here. So opening the file happens outside the loop, as does closing the file, but we're going to put closing the file out here. But then writing to the file, we want it to just go ahead and write to that file every single time the loop executes. So I go down here to where it says write text file. And you'll notice there's basically a string input. So that's what we're going to have to do. We're going to have to convert all this to strings. Okay. Now if you notice up here, there's a wire. It says refnum out. And up here it says file. And then refnum out. And then refnum. So when we open a file in LabVIEW, or create a file that we want to write to, LabVIEW assigns it basically a number so that we can keep track. So suppose I had multiple text files getting written to in the same program. I'd want to make sure that the same files match up and that I'm opening and closing the correct one. When you write to a file, you're specifying a piece of the hard drive that's going to have this information. And if you aren't careful and you close a file and then try to write to it, who knows what you're actually trying to write to? It may be nothing, and it may be just blank space, or it may be something important. And so thankfully, like, Windows and such has some protections to keep you from doing serious damage, but we really just need to keep this constant and make sure that we open, then write to, then close, and we don't ever try to write to a file after we've closed it. So that's what we've got here. We open it, we write to it, close it. And because they're wired in this way, they have to go in this order. That's just how data flows in LabVIEW. Okay, so over here at the open, got all these little tabs here. This first one says use dialog. So I'm going to go ahead and leave that open and not attach anything to it. You can hard code a path to it so that it goes to the certain spot on your hard drive. So, you know, maybe it goes to your Windows desktop or wherever you want to put it. So sometimes that's really nice, but for us, what it's going to do, as soon as we run this program, it's going to pop up a dialog box and say, where do you want to write this file? And here where it says operation open, this one I'm going to go ahead and I'm going to right click and do create constant. And got this enumerated type, but instead of open, I'm going to make it open or create. If I left it as open, it would throw an error if the file didn't already exist. So this one says basically open it if it does exist, but if it doesn't exist, go ahead and create it. The next one says how do we want to access it? We can do read, write, or read and write. So depending on what you want to do, you can change that access. We'll just leave it alone for now. The default is read and write, so we can write to it. That's what's important. And this part's an error cluster. I didn't talk much about errors this semester, but maybe at some point I'll have to do that. But anyway, so open, read, or open, write, then close. Now, what I was hoping I could do here, let's see if I've got, don't know, I'm going to try one more place here. Project files, recent files. If you remember, we wrote a little VI that so you'll actually have an easier time of this, but we wrote a little sub VI that converts these numbers into a string. So I've got to just do that real quick because I can't seem to find what I did with mine. I did have a computer crash a couple days ago, so maybe it's gone. You guys will be able to just drop that file that you wrote into place, provided you saved it, and it'll save you a little bit of time. I'm just going to have us, we're not going to write the moving average because in terms of our data analysis, we could always recalculate that if we wanted. So what's going to be important here is going to be basically the time and our let's see, the time and then our current value. So okay, so I got my tabs. I've got, so I'm doing this as fast as I can just to make all this happen. Like I say, you'll be able to use your sub VI that does this part for you. And I'm basically just going to say this is in, going to make this in milliseconds. I forget what I had you guys specify yours in. Anyway, this is just a demonstration, so you'll get the idea. Okay. All right. So there it is. It's a mess of wires. All of this part in here will be your sub VI. But for me, this is how it's going to go. Okay. So I run it. First thing that happens is we get this file pop up, and I'm going to write to the desktop here. junkyjunk.txt, and then I run this thing. Super exciting. We got our little graph here and all these data values, at least every quarter of a second, is getting recorded to our text file. So I hit stop, and I go out here to Junky Junk, and lo and behold, 0 milliseconds it was this, at 250 milliseconds, and so on. So there it is. That's all there is to it.